Hi, hello students. Good evening all. How are you? I hope all are very good. Okay, today we are going to discuss about the introduction part of coordinate geometry and distance formula also. Okay, the distance between two points in a plane tells us how far apart from the points are. First one, distance between two points on the axis. All of you have an idea about the two axes in the plane, x-axis and y-axis. Okay. On the x-axis, let us take 2 points A x10, B x20. Here have a look children. This is the x-axis, point A x10, point B x20. And 0, O is the midpoint, 0, 0. Now distance between A and B. AB equals to A and B distance equals to modulus of x2 minus x1. Okay. Now on the y-axis, let the points be C0, y1 and D0, y2. Take 2 points on the y-axis, CD. Now the distance between C and D is modulus of y2 minus y1. Okay. Here distance AB x2 minus x1 under modulus. Here distance between C and D modulus of y2 minus y1. Okay. This is the distance between 2 points on the axis. Now second one is distance between 2 points not on the axis. Furtherly, we have to find out the formula for distance between 2 points where they are not on the axis. Let us take the 2 points P x1 y1 and Q x2 y2 on the plane. Take any 2 points. See here, these 2 points doesn't lie on the axis, means x-axis and y-axis. Now the points are P x and y1 and Q x2 y2. Now we have to find out the distance between these 2 points. Okay. Draw a perpendicular from P and Q to the axis, x-axis and y-axis. Then the horizontal distance between them is x2 minus x1 under modulus, and the vertical distance between them is modulus of y2 minus y1. Now according to Pythagoras theorem, PQ means distance between P and Q. PQ equals to root of x2 minus x1 whole square plus y2 minus y1 whole square. This is called as the distance formula. Once again, I repeat it. The distance between PQ equals to root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. This is the distance formula. Here is the example. Let us take 2 points A23 and Bx6 minus 1. Take these 2 points on the plane where they are not lying on the axis. Now we have to apply the distance formula to find the distance between A and B. AB equals to root 6 minus whole square plus minus 1 minus 3 whole square. Root of 4 square plus minus 4 whole square. Root 16 plus 16 equals to root 32. That equals to 4 root 2 units. Okay. Now we have to discuss about these in clear cut way. Here have a look. These are the examples of distance. Have a look here children. Example 1. Take 2 points or 3 points. Do the points 3, 2, minus 2, minus 3 and 2, 3 from a triangle? If so, name the type of triangle form. We have to check here the distance of these 3 points. According to the distance, we have to conclude the triangle, which type of it is. Okay. Now take PQ, means the distance between P and Q equals to root of 3 minus of minus 2 whole square plus 2 minus of minus 3 whole square. That implies root 5 square plus 5 square equals to root 50, means 5 root 2. Approximately value is 7.07. Similarly, the distance between QR equals to root minus 2 whole square plus minus 3 whole square. Root minus 4 whole square plus minus 6 whole square equals to root 52. Approximate value is 7.21. Similarly, the distance between PR equals to root 3 minus 2 whole square plus 2 minus 3 whole square. Root 1 square plus minus 1 whole square equals to root 2. Root 2 value already you knew that 1.41 approximately. Since the sum of any two of these distances is greater than the third distance, therefore the points PQR form a triangle. Have a check here. This is the example. Now we have observed another example. Show that the points 1, 7, 4, 2, -1, -1 and -4, 4 are the vertices of a square. Now we have to find the distance between these 4 points separately. Let the distance between AB equals to 1 minus 4 whole square plus 7 minus 2 whole square under root equals to root 34. And the distance between BC equals to root 4 plus 1 whole square plus 2 plus 1 whole square equals to root 34. The distance between CD equals to root of minus 1 plus 4 whole square plus minus 1 minus 4 whole square equals to root 34. And lastly, the distance between DA is also root 34. Now we have to find the distance of AC and BD. These two are diagonals. The distance between A and C is root 1 plus 1 whole square plus 7 plus 1 whole square equals to root 68. And the distance between BD equals to root 4 plus 4 whole square plus 2 minus 4 whole square equals to root 68. Since AB equals to BC equals to CD equals to DA, that means all sides are equal. And AC equals to BD, that means the diagonals are also equal. Therefore, ABCD is a square. These are the properties to make a square. Now these 4 points are make a square. Okay. Now another example is here, example 3. Have a look here. The figure, the beside figure shows the arrangement of desks in a classroom. Ashima, Bharati, and Kamila are seated at A31, B64, and C86 respectively. Do you think they are seated in a line? Give reasons for your answer. Now we have to find the distance between these 3 points separately. Now we have to find the distance between AB equals to root 6 minus 3 whole square plus 4 minus 1 whole square equals to root 18. That means 3 root 2. And the distance between BC equals to root 8 minus 6 whole square plus 6 minus 4 whole square equals to root 8. That is 2 root 2. And lastly, the distance between AC equals to root 8 minus 3 whole square plus 6 minus 1 whole square equals to root 50. That is 5 root 2. Since AB plus BC equals to 3 root 2 plus 2 root 2 is equal to 5 root 2. That is the distance between AC. Now the points A, B, C are collinear. Therefore, they are in the same line. So the three girls who are Ashima, Bharati and Kamala are seated in a same line respectively. Okay. Have a look here. This is the straight line. These 3 points are lying on the same line. Okay. These are the examples. Now example 4. Find the relation between x and y such that the points xy is equidistant from the points 7, 1 and 3, 5. Okay. Now let pxy is the equidistant from a 7, 1 b to 3, 5. Now we have to find the distance between AP and BP. The distance between AP and BP, AP equals to BP. Now the point P is xy. So the distance between AP is root x minus the both sides are squaring both sides, the roots will be cancelled. Now we have to take x minus 1 whole square plus y minus 1 whole square equals to x minus 3 whole square plus y minus 5 whole square. So we have here apply the a minus b whole square formula, a square minus 2ab plus b square. Then x square minus 14x plus 49 plus y square minus 2y plus 1 equals to x square minus 6x plus 9 plus y square minus 10y plus 25. So cancelled x square y square both sides. Now we get minus 14x plus 2y plus 50 equals to minus 6x minus 10y plus 34. Now minus 8x plus 12y equals to minus 16. That is x minus 3 equals to 2, which is the required relation. Okay, the relation between the given problem is here x minus 3y equals to 2. The graph of the equation x minus 3y equals to 2 is the perpendicular bisector of AB. Here have a look children. This is the perpendicular bisector. Okay. Now we are conclude a example 5. Find a point on the y-axis which is equidistant from the points a 6 5 and b minus 4 3. Now let us take the point which we find out the point y-axis is p 0 y because the x coordinate is 0. Why? The point lies on the y-axis. So the y coordinate is y and we take x coordinate is 0. So totally the point which we to have to find is p0y. Okay. Now take the distance of these 2 points from p0y. We have to apply the distance formula, root x2 minus x1 whole square plus y2 minus y1 whole square. Now here are the roots are cancelled both sides. By squaring both sides, the roots should be cancelled. Okay. Now 6 minus 0 whole square plus 5 minus y whole square equals to minus 4 minus 0 whole square plus 3 minus y whole square. That is 36 plus 25 plus y square minus 10y equals to 16 plus 9 plus y square minus 6y. Here we apply the a minus b whole square formula. Okay. Now finally, we get 4y equals to 36. That implies y equals to 9. Therefore, the required point is 0, 9. P09. Okay. Have a look here. This is P09. Now, a point on the y-axis equidistant from two given points lies on the perpendicular bisector of the line joining those 2 points. Here, have a look here. This is the perpendicular bisector. Okay. These five are the examples of distance formula. Now we should, before I complete this topic, we have to find the key concepts. Okay. Here are the key concepts. The distance of a point from y-axis is called x-coordinate. And the distance of a point from the y-axis is y-coordinate. Okay. And the distance formula also. Okay, children, this is the topic, the introduction part of coordinate geometry and the distance formula. I think you learned it very well. If you have any doubts, please ask me in the comment section. We will meet in the next class. Okay, thank you, children.